Hello. So we're going to talk about practice problem number 9. And I want to talk to you about this because you might see something similar on the test. And so what I want to show you is that this here is from the answer key that's in the teacher manual. And you're going to see that it has in here some of the solutions. Okay, so I'm going to try to scroll down if I can. What I would like for you to do is see this here. The question is an unknown compound was decomposed into 63.2 grams of carbon, 5.26 grams of hydrogen, and 41.6 grams of oxygen. What is its empirical formula? So you're given the number of grams of several different elements or compounds, and then you need to figure out what is the formula that you're going to write out that will be the eventual compound. We also know that it's been decomposed. So you'll see here that in the final answer, we are decomposing it. Let me see if I can draw that for you here. So see, in the final answer, they're showing it to you as a decomposition. Okay, so how do we even start? Well, we know that it's a given. They've given us 63.2 grams of carbon. I've always taught you, you take what they give you and you put it over 1, right? Well, so what can we do with that? We know that we can convert grams to moles by looking at the periodic table and seeing how much AMU the carbon is. And you can see here it's 12, right? So we can say multiply the 63.2 grams of carbon, multiply that times 1 mole of carbon over 12.0 grams of carbon. And then you can see here, these grams cancel, and then you end up with just the number of moles of carbon. Okay, and that's the 5.27 here. Okay, that's one thing done. But there are 2 other things that they've given us information for. 5.26 grams of hydrogen. Okay, take what's given to you, put that over 1, and then you'll want to say times 1 mole over, look at the chart, there's 2 of the hydrogens, right? Because it's a homonuclear diatomic. It's an H2. So on the chart, it'll say 1.01, but you're going to put it over the 2.02 because we're taking the whole homonuclear diatomic rather than looking at just one little hydrogen by itself. So you take that 5.26 and you divide by 2.02, and what you end up with is crossing out these grams of H2, and your answer is 2.60 moles of hydrogen, H2. The last piece of information that they gave us is the 41.6 grams of oxygen. And we want the grams to cancel. So again, we're going to look at the periodic table and we're going to say, okay, what is oxygen? Well, oxygen is not 32, but why did they put 32? They put it because its oxygen is also a homonuclear diatomic. You're going to take that 16 and you're going to multiply it times 2, and you get that 1 mole of oxygen over 32.0 grams of oxygen. These cancel, and you get 41.6 divided by 32, which is equal to 1.30 moles of oxygen. What they've told you to do now from this point that might start getting a little bit confusing. They're using X here, right here. They're using an X, a Y, and a Z. Why are they doing that? Because you have 3 unknowns. It's not going to be overwhelming. Just bear with me for a second, okay? What we're going to do is we're going to write out the CHO that we know we have carbon, we know we have hydrogen, we know we have oxygen. Write those out because this is a decomposition thing. So we're starting out with all of them put together and then they'll decompose into their separate elements. So you put CXHYOZ. And then that's going to yield the numbers that we got from up here, okay? It's going to yield 5.27 moles of carbon. Remember, those coefficients are also moles, okay? And then plus, because these are all decomposing, so you're going to end up with carbon by itself, hydrogen by itself, oxygen by itself. And you take the next one, the 2.60, and that's going to be this here. And that's the hydrogen by itself, plus the 1.30 moles of oxygen. It's going to be right here. So what do we do now? Now we have 3 unknowns to the left. We have a bunch of numbers to the right. What are we going to do? We're going to divide by the smallest number to make them integers. The smallest number is out of 1.3, 2.6, and 5.27. The smallest one is obviously the 1.3. So this one wins the prize for going underneath everybody else. Okay, so now you're going to say 5.27, which was this up here of the carbon. Divide that by the smallest integer, which is the 1.3. That's going to give you 4. Okay, the next one is plus the hydrogen, 2.60 moles that you got from up here. And you're going to divide that by the 1.30, and that comes out to 2. All right, next is obviously 1.3 divided by 1.3. It's divided by itself, so it's going to be just a plain 1. Imagine there's a 1 here. Okay, so then what does that mean? That means our X, which was for the carbon, see here the carbon, the X is 4. The Y is the 2, and the Z is technically supposed to be a 1, but we don't use that. Why are we not using that when we are looking at it here? And the reason is because there's a 2 here, okay? So when you have that 2 there, that now makes your 2 times 2, 4. All right, so this final answer is going to be the 4 from the carbon because it's by itself. This final answer here for the H is going to be the 2 times 2, which is going to be a little 4 over here. And the final answer for here is the 1 times the 2 here. And that's obviously just 2. So your final answer, again, is C4H4O2. Okay? All right, well, I hope that helps with that one. And if you have any other questions, please let me know, and I would be happy to work through it with you. Thank you. Bye.